Hey, welcome back, everybody. Let's start off Unit 9 with Lesson 1. We're talking about special right triangles, 45, 45, 90. Gonna find out what that means here. Hang in there. Honestly, the end of geometry is like on the horizon. We're really close to being halfway through the material this semester, so hang on, you guys. You're doing great. Keep it up. Now, review problems at the top. We're still talking about triangles. Who would have thought there was like so much to know about a triangle? But in these triangles, they want us to use Pythagorean theorem. I feel like we know Pythagorean theorem. In lesson 3, we're gonna like do a lot more with it. But we're gonna use Pythagorean theorem on these right triangles to find the missing side length. We're gonna leave our answers in simplest radical form. That means we'll have to do factor trees. So check it out for number 1. The hypotenuse is c. So in this case, that's x. So it'd be 5 squared plus 5 squared equals x squared. 25 plus 25 is 50. And then I would need to square root to get x by itself and get rid of the squared. Here's where the factor tree, the simplest radical part, comes in. So I don't want to write a decimal. I want to break this thing down. So I'd break it down into probably 25 and 2. You circle all the prime numbers, all the places that you can't break down further. Getting a little squished here, but I would go 5 and 5 for 25. And then just to remind you, we haven't seen radicals this semester, but you did them last semester. To figure out how to rewrite this, you look for pairs. So I take my circled numbers. I see a pair of 5s right here. So there's 2 of them. For every pair, you bring one of those numbers out front of the radical. So I have 1 pair of 5s. I'm going to bring 1 5 out front. That 2 doesn't have a pair, so it stays underneath. Okay, so that hypotenuse is 5 radical 2. Let's do the same thing for number 2. And little whoops right there. There was a typo that x got left off. There should be an x in the problem right there. So put that on your picture. Same deal though. Pythagorean theorem, 6 radical 2 is the hypotenuse. This one might like look a little sketchy because, I mean, usually we think if we have 2 of the sides, we can do Pythagorean theorem to find the third. We're missing 2 of the sides here. We only have 1, but watch, you can actually make this work. So when I look at this, these are like terms, these x squareds, so I can actually combine those. I'm just counting how many x squareds there are. There's 1 here, 1 here. So this is actually 2 x squareds. And to simplify this, I mean, honestly, you can put it in your calculator, like, that would help. You just have to put parentheses around this. And notice when you press square root, your calculator opens parentheses, so you'd have to close that and close the bigger set and then square it. It nicely comes out to be 72. Here's why. Squared means times itself. So you do 6 radical 2 times 6 radical 2. You can multiply the numbers out front. So 6 times 6 is 36. And you can multiply the numbers underneath. So 2 times 2 is 4. And then the square root of 4 is just 2. So this is really just 36 times 2. That's where the 72 comes from. Good old radical rules. All right, from here, now I can just divide by 2. So I've got x squared equals 36. And then I'm going to square root that. Technically, there's 2 answers, but we're talking triangles, so only 6 makes sense. All right, so this is 6, and this side is 6. Those 2 sides are both called x. Okay, there's a point here, people, why we did those problems. And that's a lot of work, especially that one. Like, yuck, that was a lot of work. Basically, the moral of the story here is there's a pattern with what's happening. These are specific types of triangles. They are both isosceles. Spelling doesn't count. They are both isosceles, meaning like 2 of the sides are the same. Same thing here, those 2 sides are the same. They're isosceles right triangles. Okay, that means they have the angle measures. Any isosceles right triangle has angle measures 45 degrees, 45 degrees, 90 degrees. Hence the title of the lesson. Think isosceles triangles. If these two sides are the same, these two angles are the same. So they always work out to be 45. Not necessary to like stick in the 45s right there, but we will. Okay, so anytime you have a triangle that's isosceles and right, it's a 45, 45, 90 degree triangle. There's a pattern that's happening, and we can use this pattern that I'm about to show you as a shortcut to doing all of this work. Like that was a lot. I'm about to make your life so much easier, okay? So watch, we won't have to do Pythagorean theorem at all. Yay. We don't love math, but we do love shortcuts maybe. So here it is. This is like the big thing to know. Okay, anytime you have a right triangle, it's gonna end up being isosceles, and the angles are 45, 45, 90. This only works for right triangles that have 45, 45, 90 degrees, okay? Keep that in mind. Basically, the legs are always the same length because it's isosceles. So I'm gonna write over here, my little bullet points are like my most important things for today. The legs are always congruent. For the sake of like generalizing on my picture right here, I'm gonna call them both X. They are always the same. Now, the hypotenuse, we gotta figure that out. And we can discover it up here, you guys. Like, check it out. I'll highlight the side lengths. 5, 5, see, legs are the same. Hypotenuse is 5, radical 2. 6, 6, legs are the same. Hypotenuse was 6, radical 2. Ooh, bad glare. So if you can tell a pattern here, the legs are the same on both of these triangles, and look how the legs are related to the hypotenuse. Maybe you can tell that like they just took the leg number and they stuck a radical 2 on it. And that's how they got the length of the hypotenuse. So that's exactly what I'm going to write down here. To find the hypotenuse in a 45, 45, 90 triangle, you just take your leg and you multiply it by radical 2. And that's how you get the hypotenuse. So here I'm going to call this leg, which is X, X radical 2. Are you weirded out yet? All right, to be honest, you guys, this is the big thing you need to know. Right there, I'm gonna use that for basically every problem. Hypotenuse equals leg times radical 2. It'll be written on the board for you. Here we go, let's practice it. So first things first, we're gonna practice finding the length of a hypotenuse in a 45, 45, 90, and you should verify that these are 45, 45, 90s before you start. So yeah, if that's 90 and that's 45, I mean, just to prove it to you, that third angle would be 45. So, okay, sweet. My shortcut here can work. I'm not gonna do Pythagorean theorem, and realistically, I couldn't do Pythagorean theorem. The question often comes up, why can't I do SOHCAHTOA to find X? You could, but let me tell you, they're gonna always say, write it in simplest radical form. SOHCAHTOA is never going to give that to you. It's always going to give you a nasty decimal. So for that reason, we need these shortcuts. And they're quicker than SOHCAHTOA, to be honest. So watch here. The legs should be the same. So, okay, this is the hypotenuse. Let's all be clear of that across from the 90. So if they ask me the legs, if this one's 9, this one's 9. Legs are congruent. To get the hypotenuse, I don't have to do anything. X is the hypotenuse. I'm going to use this shortcut right here. The hypotenuse, X, should equal the leg, which is 9, times radical 2. You guys, this is solved. Like I just wrote the answer. 9 radical 2. That is it. That's so much quicker than doing Pythagorean theorem or SOHCAHTOA. Okay, on the next one. Now, technically, I look at this and I'm like, oh shoot, they didn't write 45, 45, 90. Can I use this? Well, I noticed that it's isosceles and it's right. Those guys are always 45, 45, 90s. Because remember, those angles should be the same. So if I do 180 and I take off the 90 and then I split that in 2, those are both 45s. So if you see isosceles and right, it's automatically 45, 45, 90. Anyways, the shortcut would work. The legs would both be 5 radical 3, and y is the hypotenuse here, across from the 90. So the hypotenuse y should equal my leg, 5 radical 3, times radical 2. Sometimes some radical stuff might come back to get you here, so you just have to remember, how do I multiply that? Well, you can multiply the numbers out front and the numbers underneath. So there's just a 1 right there, so I can do 5 times 1 to get my new number out front, which would be 5. And then I can do the numbers underneath, 3 times 2, so that would be my new number underneath, which would be 6. So the y value would just be 5 radical 6. Lots of multiplying by radical 2, and here on the back, dividing by radical 2. So same concept. The only thing, honestly, you guys, you need to know for 45, 45, 90s is this. Hypotenuse equals leg times radical 2. You will get so sick of hearing me say that. So on here, and I guess this should probably, oh no, it doesn't need to say. Maybe you think this isn't 45, 45, 90, but it's a right triangle. That's isosceles because those legs are both x. So I'm good to go. I'm going to use my setup here and just plug in the pieces where they fit. So here's my hypotenuse. These are both legs. So the hypotenuse, which is 6, should equal the leg times radical 2. Here's where you have to work backwards and divide by radical 2 to solve that for x. Now, I don't know if you guys remember this. I hinted at it a little bit before the last test, but you can't write this as your answer. And it should say simplest radical form. It always will. You can't leave this as your answer because you can't leave a radical on bottom. You have to do what's called rationalizing the denominator. So to do that, you need to get rid of that radical on bottom. I don't know if you remember this from algebra, but whatever the denominator is, you just multiply by that exact same thing on top and bottom. So that would give me on top, and this kind of looks janky, but always put the number out front. It'd be like 6 radical 2. On the bottom, and you can't multiply those to get 12 because it's a plain number and a radical. On the bottom, you can multiply those. Square root 2 times square root 2 would be square root of 4. And the square root of 4 is just 2. So you're kind of looking at that right there, which that can be simplified. You can divide the numbers out front. 6 divided by 2 would just be 3, and then stick your radical 2 back on it. Isn't that fun? All right, watch, I'll do one more. So 45, 45, 90. Same setup. I'm going to do it the other way. Doesn't matter if you flip-flop it. You might be able to see the work better this way. But basically, leg times radical 2. So leg times radical 2 equals hypotenuse. I just got to solve that for x. Divide by radical 2. Rationalize the denominator. Multiply by radical 2 over radical 2. Okay, shortcut this a little bit. On the top, plain number, radical number. Stick them together. On the bottom, radical 2 times radical 2 is radical 4. Basically, guys, the radical just always goes away, and it's just 2. Then divide those guys, 5 radical 2. All right, on the bottom, last one, real world connection. We love these. High school softball diamond is a square. Not pretty. What do I know about a square? I know that all of these are right angles. I've drawn better squares in my life, huh? The distance from base to base. This applies to me. I played softball. Base to base is 60 feet. To the nearest foot, how far does the catcher, so this is home down here, if you're not sure. This is home. This is second. How far does the catcher throw the ball from home to second? All right. I just drew in a diagonal. The diagonals cut the vertices in half in a square. Quadrilaterals coming back. So these would be 45, 45, 90s. I'm just going to look at half of it. Okay, watch. Here's how this comes in handy. Hypotenuse equals leg times radical 2. So my goal is to find that x. So I'm going to take one of the legs, and I'm just looking here. The leg is 60 times radical 2. That should equal x. It didn't say, nearest foot. So plug that into your calculator. see what you get, make sure you write your answer down, and that's lesson 1.